before we finish with this demo, I would like to show you how to run this program in debugging environment. Under debug menu, there are two options to start our program. What we did before, we were using the start without debugging or pressing Ctrl F5 to start the program. The second option is to start debugging session. In this debugging session, the debugger program will be loaded into memory before our program, and the debugger will notify the CPU that it needs to execute the program in a step-by-step mode. After each compiled instruction, our program will stop and the debugger will gain the control over it. Although the execution will be going truly step-by-step and therefore significantly slower, the debugger by default will not stop and will just continue to execute our program as normal. However, we have a chance here to set a breakpoint. For instance, if I want to be able to stop before this call into a ping function, you can click here on the margin and you see this round marker appears, or you can right click on specific line and choose breakpoint insert. So that would do the same thing. So what breakpoint does is that when the debugger right here will get to this place in our program, the execution will stop and we'll have a chance to dynamically, interactively examine the runtime environment. So let's give this a try. So I'm starting my debugging session, which starts running just like normal program. So right now we're waiting for user input on this line, which basically the character input device is waiting for us to print something and hit enter. I will set it to 3 to shorten the number of calls that we execute in our program. So my choice here is 3, and I press enter, and you can see that after I pressed enter, the debugger stops execution on this line. This little arrow, this little yellow arrow indicates which line of code is the next statement to execute, and that means that this statement hasn't executed yet. It will execute if we press there are two options here as well. You can press F10 to step over it, or you can press F11 to step into the call and see what happens inside the function that is being invoked. Of course, if I just step over, it will show me all of the messages right here. If I bring it back, you see it already did all the prints, 3 of them, and now I'm just ready to exit the program. So this is not exactly what I would like to do in this debugging session. So it's quite normal to just click debug and say stop debugging. And so this time I will reconfigure, or rather I will take a different action and I will step into the call to see what happens inside this function. So this time I'm clicking again debug, start debugging. The program starts to execute. It asks me how many times I want to play. Again, I will say 3. And this time again, I stop on this line. And in this mode, down here, I have a few additional panels which are available from within the debugging environment. And I can examine my local variables, for example. So main function has this local variable name shot count, and you see that the debugger can indicate to me that it has value of 3 and its time and so forth. So when you have multiple local variables, it's easy to examine their values, and you can even change them right here. You can double click and change the value. So this time, instead of stepping over the first call into ping, I will use debugging option F11 to step into this call. And you can see that the yellow marker here is now showing me the next instruction to execute, and now it corresponds to this opening brace. Remember, opening brace and the closing brace construct and remove a stack frame from computer memory. So they actually have executable code associated with them. And so this will happen as part of this. So now I can press F10 to step over it. And once again, the local values, I still have this shot count, which is this local parameter, the input parameter of my function, and it's still 3. It hasn't changed. So I will step over by pressing F10 over this if statement, and of course it was not equal to 0, so we continue with the rest of this code. Minus minus will decrement the count, and you see it changed to 2. The next thing, we print ping right here in this next step. Now we're done with this. I keep pressing F10, and now I'm curious to see what happens inside pawn. So again, I will press F11 to step into this call. Right, so I'm pressing F11 inside this function. Now everything freezes everywhere, and except now is the next line of code to execute. And now I will switch to F10, which is a little faster. And here again, the next check is, and this time, because we already decremented the counter, now it's 2, so it's still not 0. Go to the next line, F10, minus minus, so the shot count becomes 1. Now notice here there's also another very useful display or tool within debugging environment, which is called a call stack. Imagine that we already had called function main, so the operating system or debugging environment invoked function main. So it gets placed on the stack. So it has a fully constructed stack frame right here that corresponds to this function main. And debugging environment shows us that this stack frame is right here in memory. It's present and it's still waiting to continue. Then function main invoke ping. And so now on the next line, you can see right here we have a ping function on the stack, which means that this ping function also has its stack frame constructed with all of its local variables, and this next line indicates this, right? So we have an active stack frame, and therefore this function is still waiting to complete because it's waiting for the next call into pawn to complete. And on the third line, we also see right here on the call stack that the pawn function, of course, is also still active. In fact, we're now looking at the next step to execute right here to print this message. And so therefore, this next line also shows us that the pawn is also still on the stack, and we have an active stack frame in memory, and this function is in progress. And it's right now, it's the current function that's running. Okay, so we're about to print pawn, and we print it. I press F10. You see that the next message is displayed. And then again, before going to the next action, I will press F11 to see the invocation of ping again. And notice what happens on the call stack. I press F11 just as my intention is to step into ping one more time. And you see now the ping is being called twice. And every time it gets invoked, it will have its own stack frame constructed. And basically, we now have 4 functions on the call stack: main, ping, pawn, and another call into ping. So this time, shot count is equal to 1. So, okay, we can try pressing F10, 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 and finally count becomes 0. But now we're already executing this function, so I press F10 again. So this is our third time that we print something on computer screen right here, and it happens to be inside the ping function. As before, I will click on the pawn, F11, and I'm entering into the pawn, and this time we have main and 4 calls into ping and pawn. But this time shot count is equal to 0, and therefore this if statement will be checking a true condition. So I'll just press F10 and see what happens on this line. F10, and the control is transferred to the closing brace. So this return statement, just before getting right back to where we came from, it transfers controls to its control to the closing bracket, so that the local variables placeholder, the stack frame for this function, will be removed, and its memory given back to the operating system. So now from here, so from return, we jump over here in this debugging session, and I press F10 again, and we return from where we came from. And now if I be pressing F10 to return from these function calls, watch what happens right here on the stack. I keep going F10, 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 and you see this area begins to shrink, because we begin to just return and return and return and return from our function calls. And I keep doing it, and eventually we come back to main. So this time everything's already printed, all the counting is already complete. We return, and then I press F10 this time and F10 again, and we print game over, and we return. All right, so this is just a demonstration of what you can do to trace and visualize execution of your program in debugging mode. So be aware of it, and this is very useful if you're trying to find out a problem like a logical error, or some condition isn't working, or something similar that is not a syntax error that you get during building your code, but rather it's at runtime it doesn't behave the way you expect. So this would be a choice for you to try. And normally I almost never finish my debugging sessions. I just go to debug and say stop debugging as soon as I have visualized what I wanted to see during this debugging session. So stop debugging just forces the process to stop, and I return back to my source editor. What I would advise also, that once your debugging is complete and you know that you no longer need this breakpoint, I recommend that you delete it. If for some reason, and by simply pressing on it or toggling it off. Also, if this source file is not displayed, you can always go to debug windows and breakpoints. So the breakpoints window will show you what breakpoints you have, and you can right here you can just delete selected breakpoints and get rid of breakpoints that you're no longer using. It's a good practice to just use them temporarily and then get rid of these breakpoints.